because I had a bunch of people out yesterday. This is page 31, 32. Today's the 24th. And this is lesson 13, Laws of Exponents. I wrote at the top, this last block, I wrote like 4x plus 3x, something like that. And we don't want to forget, we do this in equations, we do it all the time, and that's just 7x. We're going to start, instead of stating it as a rule, I'm just giving it as an example. So we're going to, what this rule says is when you multiply like bases, that you add their exponents. So I did not in any of the classes go through and say this is called the base and this is called the exponent. I might needed to do that. Yes, I made the assumption that you knew what those were. But let's see what that means. And so underneath, put you 5x's times 3x's. Now, if I've got 5x's times 3x's, how many x's am I multiplying? How many total x's are right here? 8. So I've got 5x to the 5 plus 3, which is the shortcut, and you get x to the 8th. When you multiply like bases, you're just counting your x's, is what you're doing. Now, on the second one, I'm going to actually do that as a multiplication problem. 4x times 3x. I'm going to show you the difference. Now, these had 1's in front of them, so you're still multiplying. 1 times 1 is 1. There's still a 1 in front of that. But look at this one. So 4 times 3 is still 12, like it's always been. Multiplication tables, multiplication, you know, they're there. But now look at this one. When you multiply like bases, you add their exponents, and those are both understood to be 1's. So you have x squared. See the difference? This is what you get when you add them. This is what you get when you multiply them. Number 3. Let's do just a couple more of these, and then we'll jump into the second law of exponents. Let's do 5m squared n. I don't think you have any in classwork that have 3 in them, but 2, 3, they're about as equal. Several of your problems use parentheses. I use dots. Times 6mn times negative m cubed. Now recognize that's a negative 1 in front of that. So the first thing you want to do is just like we did the 4 times 3. You want to do your 5 times your 6 times your negative 1. So what are those multiplied? Negative 30. So we get the coefficients out of the way first. Now how many m's are you multiplying? Just like we did up here. You were multiplying 8 x's. Here we were multiplying 2 x's. So how many m's are you multiplying? How many? 6. You got 2 here and 1 here and 3 here. Do I need to write them out? M times m, 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 m. No, that's negative 1 in front of the variable's not negative, but the number in front of it was. That's where that negative came from right there. So that's why I did it that way. You know, if I'd have put negative 5, you wouldn't have questioned it. But it's the number is the coefficient. So you get those out of the way first. Now you just do your, so I've got 6 m's and how many n's? 2. 2 to the 4th times 2 to the 3rd. And I'm going to tell you, now you know the exponent's going to be 7. I don't think that's a question. But the question is, what is down here? You've got 4 2's times 3 2's. What am I multiplying, 2's or 4's? I'm multiplying 2's and I have 7 of them, right? But because if this is x to the 5th, x to the 3rd, x to the 5 plus 3, 2 to the 4th, 2 to the 3rd, 2 to the 7th. Now, just a review of your calculator. You still got it out? If I want to get 2 to the 7th on my calculator, what's the quickest way to do that, especially on the ACT? Use your little house top right here. Yeah, 2, and then the house top, and 7, and it's 128. And I'll write that over there if you want me to. 2 house top 7. Okay, let's do the second law of exponents. The second law of exponents is called, that's just a product of powers. So now let's do, and I'm going to use these numbers for the reason, because I'm going to show you that it's different. We're going to do x to the 5th to the 3rd. Now see, these are not the same problems. Now think about what that means. If I have 8 to the 3rd, that means 8 times 8 times 8. So if I have x to the 5th to the 3rd, that means x to the 5th times x to the 5th times x to the 5th. That means 3 of those multiplied together. Now add your exponents like we did in 1 through 4, and you get x to the 15th. Do you see a shortcut? Yeah, just multiply them. Now look at the difference, and this is where people get confused. So you add them up here, and you multiply them down here, but they're two separate problems. So be careful on that. Now, tying that with it, it's the same problem, but with more things in the parentheses. Let's do m to the fourth, n to the second, all raised to the fourth power. So I've got m to the fourth raised to the fourth, same rule here, m to the 16th, n to the second to the fourth, n to the 8th. Okay, number 7. Let's do negative 3 a cubed. I'm not big on using b's, but I just make sure it doesn't look like a 6, and then c squared. Sometimes I'll just do a's and c's. Now, this is a neat one, and I want you to see it on the calculator. This is something else they'll try to trick you on the ACT. First, oh, I left mine. Let's see. That's, let's see. Let me make sure I got it copied down right. Then there's a squared out here. So we got a square. See here, we did 1 to the 4th, which is 1. We just kind of did that understood. But now we got a negative 3 squared. Well, what is negative 3 squared? Negative 3 times negative 3 is positive 9. I'm going to put positive for a reason, because I want you to see, if I go to my calculator and if I type negative 3, and this is one of those, and you can either hit the squared like that, or you can hit it over here raised to the 2, it's not going to give me positive 9. It's going to give me negative 9. It's because I didn't tell it the right problem. Let me show you the difference. Negative 3 squared like this, and see on the ACT it would have negative 9 is one answer and positive 9 is the other. That means without, like that, that means negative 1 times 3 squared. You're not squaring the negative, and that's negative 9. But if you're going, and here's the tricky part, see, because negative 3 is not necessarily in parentheses when you square it, but on your calculator, you're going to, when I said what's negative 3 squared, you actually have to type it like this, and people miss it all the time. And it's positive 9. And a lot of times, I don't even type the negative. If I'm doing negative 7 to the 3rd power, well, I know negative times negative times negative is going to be negative. And so I just put my sign and then worry about the number. And that's going to be positive 9. So look at the difference in those. It will get you in a lot of places on the ACT. Now, then a to the 6. Now, what about b? What's the understood exponent right here? Understood is a 1. And so you got 1 times 2 is b to the 2, and then c to the 4th. Now, we'll talk about what's the difference in a 0 exponent on Monday. Number 8, one more. 4m n to the, that glares, it's hard for me to say, cubed and then cubed. Now, so I'm on the ACT. I'm like, what's 4 cubed? So just 4 raised to the 3rd is 64. And then m to the 1 times 3 and n to the 3 times 3. Number 9. 9 through 11 are the last rule we're going to do today, and then 12 is going to tie a couple of these together. Now this is, I'm going to actually give you 9 and 10 at the same time, because I'm going to tell you how books teach it and how Miss Gately and I started teaching it years ago. And people did so much better on it. And it's going to make negative exponents better too, easier too. Now the rule, if you Google it, the rule's going to say subtract your exponents. But there's also a rule that says never leave negative exponents. Don't leave a negative answer. Well, look what happens. If you say 5 minus 3, okay, that's cool. We get x to the 2. But if I have 4 over 7, 4 minus 7 is negative 3, and then I got to get rid of that negative. We'll talk about that on Monday. But we started doing it like this. So write on your paper, and this is the only time I write it. I got 5x's over 3x's. And I literally start marking out what they have alike, just like dividing by the 2's there. Now this is the question I ask you. Instead of saying what's the answer, I say how many x's are left and where are they? Which I mean top or bottom, numerator, denominator. So in this case, how many x's are left? 2, and they're on the top. And there's always understood numbers here. In this case, there's an understood 1. You can leave it like that. Usually you're going to reduce it to just x squared. It's running slow. So doing the same thing on this one, I'm not going to write them out and mark them out, but let's just talk about it. If you have 4 on top and 7 on the bottom and you start marking them out, how many are you going to have left over?
3
And where are they?
on the bottom.
Okay, so tie that together, and I've got room to do 12 down here, but I'm going to actually do it at the top of page 33. This one's very similar to what we just did. Let's do 16 x to the 5th, y to the 3rd, over 18 x y to the 5th. Now, do you know the quick ways to reduce fractions on your calculator? I mean, I would hope y'all would know just to divide by 2 over 2, but if you had big numbers, one way, and I've got to update yours, Keaton, is to, and yeah, I think it was his needs it too, but I can do that, which y'all do alpha, or do you do second y equals, or something, alpha y equals up there. But anyway, alpha x, you can do it this way. I don't. To me, it's just a little longer. I don't know why. And I can do 16 and then arrow down and put the 18. Now, the nice thing about that, when you hit enter, it gives you the reduced numbers. So 16 over 18 is going to be 8/9. Now, I like to do it this way. 16 over 18 means 16 divided by 18. So I do 16 divided by 18, treat it as a division problem, and then I just do math frac and change it back to a fraction. To me, that's quicker. I don't know why. That's just the way I've always done it. So either way, if you need to reduce a fraction, that's a great way on the ACT. What about x's? How many x's do I have left, and where are they?
You got 5 x's. Well, no, you got 4 x's left.
Where?
On the top.
On top. And what about the y's?
You would have 2 left on the
2 on the
bottom.
bottom. You see that, Liam? Okay, you can do yours at the bottom if you want to. I'm on the top of page 33. It's just awkward me to have to write way down there. So, did you get it? Y'all get that one? Okay, this is the last one. 12 says, now there's a big negative out there, and it's usually even with the fraction bar. So I'm going to do it like that, and I've got 5x squared y. They can do parentheses or dots, times 2xy cubed, all over 8xy to the 4th. Now, you can start canceling like it is, but sometimes you'll forget variables. To me, it's easier to simplify it and then reduce. Now, let's talk about that negative. The whole fraction here is positive 5, positive 2, positive 8. 10 over 8, and then times a negative is still going to be negative. So you'd have to watch. If there had been a negative 2 in here, see, it'd be negative over positive. Negative times negative would have been positive. So you got to watch that. Just be careful. So let's do we've got 3 x's on. I'm going back to the first law. So I've got 3 x's on top. Like, look at number 1 and 2. That'll help you. And I've got 4 y's on top. I've got 1 x on the bottom and 4 y's on the bottom. So I have a negative. Now, what does 10/8 reduce to? You'll do it on your calculator, do it in your head, divide by 2 over 2, 5 over 4. How many x's left? Where? Liam, tell me.
2 x's on top.
And what about the y's, Liam?
They're just canceled.
They're gone.